Okay, things are starting to get fun here with number 6. We have two objects that are moving at different speeds, and then at the end, so it's a salamander and a carp, it says the salamander catches the carp, and so at the end they're moving with the same velocity, so the final velocity is of the carp and the salamander. Um, if you want to watch a nature show, you'll probably understand what's going on quite well here. They're both moving at 3.5 meters per second. Okay, and so we would call this a perfectly inelastic collision, where the objects have stuck together and now they move as one object. So we don't have to think of them as separate masses at the end of this collision. We can think of them as the same mass because they're all moving together. So the salamander's mass is what we don't know. That's the final 5 words of this question. Say, what is the salamander's mass? And so that's what we don't know. We know everything else. We know initial velocity of the salamander and the carp's mass. And so we're going to set this up, the conservation of momentum. This is number 6, by the way. So let's think about it. We've got, if you add up all of the momentum at the beginning of the collision or before the collision, it's equal to all the momentum at the end of the collision. And notice I drew arrows over the momentum symbol P because these are vectors, which means they have direction. Where do they get the direction from? Well, mass can't be positive and negative, so the direction comes from the velocity. And you'll notice I wrote both the velocities as positive. And that's because they're both moving in the same direction, to the right. If they were moving opposite directions, one of these would be positive, one would be negative. So that sign is just indicating the direction of the velocity and therefore the direction of the momentum. So at the beginning of this, we have the mass of the salamander times 3.6, or 3.6 m. We have 2.2 times 5. That is the momentum of the carp. And whatever momentum the system has at the beginning, since this is a closed system, at the end of this collision, they should have an equal amount of momentum. And how is that momentum made up? Well, you could write it like this: mass of the salamander times 3.5 plus mass of the carp times 3.5. But that's totally unnecessary. They both are going 3.5 meters per second, and that would be the mass of the salamander plus the mass of the carp, which we actually do know is 5. Okay, so now we can do a little bit of simplifying. On the left side, I'll do 2.2 times 5 to get 11. So it's 3.6 mass of the salamander plus 11, and that is kilogram times meter per second. And over here, I'm distributing this 3.5 to both of these terms, plus 15, 17 and a half. Okay. So now we need to solve this. All right, the physics is done. Now we are just solving for the mass of the salamander. So I need all the variables, the same variables on the same side. Okay, because if I want to get mass of salamander equals a number, then I need the mass of the salamander to all be on one side. So this would be 0.1 mass of the salamander plus 11 equals, that cancels out, 17.5. Next step, we'll subtract 11 from both sides. Equals 6.5. And then you take 6.5, you divide it by 0.1, and we get that the mass of the salamander, excuse me, ooh, I thought I hit restart, it's fine, 65 kilograms. If you look at the problem, it's got 3 significant digits everywhere, so you could put 0.0, 65.0 kilograms. And that is that one.